Hello. So, just want to have a look at the last part of hypothesis testing, which is to do with errors. There are two types of errors that we can make while we are hypothesis testing, and I always like to start off with this photograph here of a pregnancy test. So, a pregnancy test you can think of as a hypothesis test, where we will have the hypotheses. And hopefully you can understand that our null hypothesis should be that you're not pregnant, because the majority of humans, and the kind of standard form for a human, is to not be pregnant. Not preg. And then you basically want to test, you test hormone levels, things like that, to see whether they are pregnant or not. And then if you reject they're not pregnant, then they must be pregnant. There we go. So again, that's my way of thinking of these errors here now, because a type 1 error is, hopefully, you can see here that the doctor is telling an old gentleman that he is pregnant. Now, okay, this is unrealistic, but the point is there is quite obvious that that man is not pregnant. It is quite obvious, as he is an old man, that he is not pregnant. So in this case, H0 is true. Our null hypothesis is true. He is not pregnant. He's the standard form for a human. He's in the kind of, regular phase of human life. H0 is true. But we reject it. And that's what a type 1 error is. We should be sticking with H0. We should say there's not enough evidence to reject H0 here. But we actually come to the conclusion that we should reject H0, even though it's true. That's what a type 1 error is. Now, a type 2 error here, this lady has what we can assume is a baby in her womb, and so the doctor here is telling her that she's not pregnant. Silly doctor. So quite obviously here, H0 is false. Our null hypothesis is false, and H1 is true. So in this case, we should be rejecting H0, but we are not. So H0 is false. But we don't reject it. So these are the two errors that we can make. Type 1 error, okay, telling an old man that he's pregnant, maybe a bit of a shock to him, but it's not really that bad, I guess, maybe. Type 2 error here, okay, telling that lady that she's not pregnant when she actually is probably a little bit worse. The same maybe as if you were testing for a disease, then a type 1 error, okay, is bad because you're telling the person, okay, you do have this disease, when they actually don't, which I guess isn't as bad, maybe, because at least then they find out that they don't have the disease later on, which is probably better, whereas a type 2 error is telling someone that they don't have a disease when they actually do, which is probably a bit more dangerous. Anyway, we basically will have to have a look at what the probability of a type 1 and a type 2 error is, and quite lucky that we've kind of already thought of the probability of a type 1 error, because probability of a type 1 error is the probability of H0 being true but rejecting it. H0 being true but going with H1 instead. Well, we always assume H0 is true in our hypothesis testing. We always assume H0 is true. That is, for us, the p-value is whatever's. We always put that into our binomial. So we always assume H0 is true. So when we reject it, that's basically when our p-value is less than alpha. So alpha here is our significance level, is actually the probability of making a type 1 error, because what we're working out is the probability of whatever our sample is if H naught is true. So we work out that probability. How likely is this sample to happen if H naught is true? And it's just when it's unlikely, so when that probability is small, do we then say, yeah, okay, I've got enough evidence to reject H naught. Again, we're not definite because there's still a really small chance that H naught is true. That's just what we've worked out. What is the likelihood of H naught being true? So that is the probability of us making a type 1 error in that scenario. And again, we can control that. We can just be more strict. We can put a smaller significance level, take it to 1%, maybe take it to 0.1% if you want. So we can control that quite well. Now, in a type 2 error, so the probability of a type 2 error, this is a bit different. Because in this case, we will need to know that H naught isn't true. So we will need well, for us it's about p's, a proportion that suits H1. And basically we want the probability then of us not rejecting H naught. And then we want the probability of not being in the critical region. Because if I'm in the critical region, then I'm going to reject H naught. If you remember, the critical region are the values of which I reject H naught. So the probability of being in the critical region is the probability of rejecting H naught. For a type 2 error, I don't want to reject H naught. I want to stick with H naught. So I don't want to be in the critical region. So I want the probability of not being in the critical region for this new proportion that basically satisfies H1. So they'll have to give us a new proportion there, just for us to be able to work out a type 2 error. The probability, of a type 2 error. The probability of a type 1 error is always your significance level. Probability of a type 2 error, you'll get a new p to put in your binomial, a new proportion. That's the actual fact, the true proportion, and it will suit H1. I feel like I should probably give you a quick example here. So if I had H naught, I don't know, the proportion of people that use fairy liquid is 80%, and someone comes along and says, no, I think it's less than that. So they would say, oh, from knowing actually only 70%, maybe only 70%, which in this case is less than 0.8, so that suits H1. Only 70% of people use fairy liquid. What's the probability of a type 2 error in that case? And then you'd have to obviously know the critical region and work out the probability of the opposite of that critical region. The probability of not being in that critical region there. If p was now 0.7, and again they'd have to give you that in the question. We'll have a look at a few examples in the next video. The most important thing here is type 1 error, rejecting the null hypothesis when it's actually true. Type 2 error, not rejecting the null hypothesis when we should